Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to talk about a bunch of topics related to classes, objects, and methods. So we're going to start off by talking about object references and how the .NET runtime manages the memory that your objects use. Then we'll talk a bit more about passing object references as input parameters to methods like we did in the previous lesson. Let's look into that a little bit more and see what's actually happening. We'll talk about constructors, which are special methods that are fired off automatically whenever you create a new instance of a class. And then finally, we'll talk about static methods and properties, which are utilized often in the .NET Framework class library. So there's an important distinction to understand in .NET and C# whenever you're working with classes and objects. If you'll see, we have the code sample from the previous video. Simple classes open kind of to the state where we left it previously. And so we have this line of code, car, my new car equals new car. And before we just gloss over that and keep moving on, let's really think about what's happening here. So whenever we call the new keyword, the .NET Framework then goes off and creates a spot in the computer's memory sufficiently large enough to hold a new instance of our car class. The computer's memory has addresses similar to our street addresses for our home or apartment, and it takes note of where it put that new instance of the car class. It writes it down on a little post-it note, and it delivers it back to you, the software developer, to use as you see fit. And so that address is then saved in this variable, in this specific instance, my new car. So my new car is simply an address. It's simply a reference to the instance of the car class that's stored in the computer's memory. Whenever you need to work with an instance of the car class, you just use my new car, and the .NET Framework will take care of the rest. It gives you the illusion that you're working with the actual object, but you're really just holding on to a reference to that object that's stored in memory. So kind of to give you an analogy here, what I would say is that it's like the bucket in memory. It gives you a handle so that you can hold on to that bucket. Okay, that's just another way of thinking of it. So the .NET Framework runtime will go through and it will see and make sure that everything that's in memory is currently being used. And it does that by seeing how many handles each object stored in memory are attached to the buckets. All right, so how many objects have references that are currently being used. If we as software developers are no longer holding on to a reference to an object in memory, the .NET Framework, as it goes around looking at each object's references, will take note of it, and then a process called garbage collection will begin, whereby it'll remove items from memory and conserve memory, manage memory on your behalf. Okay, so to kind of illustrate some of these concepts that we're talking about, let's do this. Car, my other car equals my new car. All right, so what have I done right there? I've created a new object? No. I created a new reference, a new handle to a bucket. And then I'm associating that handle with a bucket that's already in computer's memory by borrowing the existing handle's reference. So I'm using this reference to create a new reference. Now I have two references to an object in the computer's memory. Okay? And now I can do something like this. Comment that out. All right, so now what would you expect to see displayed on screen? The word Toyota. Why? Because my other car is referencing the same object in memory that my new car is referencing. So when we set the value of make, the property make, to Toyota, we're merely pointing to that same position in memory and getting the make property and its value, in this case Toyota. All right, so as references to that object in memory go out of scope or are set to null, then the reference count, in other words, the number of handles that are associated with that bucket, start to approach 0. And when there are no more references to that position, that bucket in memory, then it will be removed through garbage collection by the .NET runtime. We could do something like this. And while it may not happen immediately, it will then be the object in memory will be removed from usage, and we can never get back. It's like a balloon. When you cut off the last string to the balloon, it floats out into space. You can't get to it anymore. That's exactly what happens. We have no more references to that object in memory. We can't get back to it. All right, so let's comment all this stuff out. Now, I really said a lot of that to say this. When you pass an object like we did here as an input parameter to a method, you're only passing a copy of the original reference, or rather a copy of the original handle to the bucket. If you want to point that reference to a new instance of a class, you can do it temporarily within the body of that method. However, it'll make no lasting change outside of the method. You only modified the copy of the reference, not the original reference, and definitely not the original object instance in memory. So what did I mean by that? Well, let's write a little code here to kind of illustrate this. What I want to do is create another helper method. I'm going to call this private static void do by value car. And what I'm going to do is take car and set it equal to a new car. Whatever car you gave me, we're going to pass on that and create a new object in memory, and now point the reference to the new one. So let's go car.make equals BMW. So that when we come back up here, let me do console.writeLine, my new car dot make, we want to see what gets output. So I'm going to call this do by value. I'm going to pass in my new car. All right, so my new car originally was set to Toyota, but we're going to pass it to do by value. Do by value is going to create a new instance of the car class and set its make to BMW. So then once we come out of that method call, what would we expect my new car, what would its make be? So let's run the application, and you can see it's still Toyota, and that was the point that I'm trying to make. All we're doing when we pass in a reference to an object in memory, we're passing a copy of it by default. So you might wonder yourself, what if I really wanted to make a change to this original reference and I wanted this to work kind of the way that you might intuitively think it would work in this case? We want to point car, or really what we want to do is point my new car to a whole new reference, or I'm sorry, new object in the computer's memory. How would we do that? We would do that by passing the car reference by ref, or by reference. Or it's a little confusing here, but watch what I do. So let's create a second example here, and we're going to call private static void do by reference, and I'm going to use the ref keyword car, and it's going to be exactly the same. That is the only difference between these two blocks of code. And up here, what I'll do is kind of extend this example. So let's go console.writeLine before. So here's the before. We know that we're going to start off with my new car, and we'll be able to tell it by the fact that its make is Toyota. And so then we're going to call do by value. We've already seen that at work. So let's do this. Passing by value. And then we're going to call do by reference my new car. All right, so in all three cases, we're printing out what my new car's make is. Now notice I'm getting an error on this line of code, and that is because when we use this ref keyword, we're going to have to use it here as well to indicate that we're passing in the actual reference. We're not passing in a copy like we're doing here. We're going to pass in the actual reference. So whatever changes are made to that reference, in other words, if we're going to point it to a new instance of car in the computer's memory, then we want that to actually take hold and be applied then to our actual reference, not just the copy. Let's run the application, and you can see how this modifies the fact that my new car is pointed to a new spot in memory now, okay? And to kind of extend this thought out, this is not exclusive to what we know about classes. This will actually work with simple types as well. So I have another project. This will be available to you where you downloaded the source code for this video. You can see here that I have essentially the same situation except with just using integers, so this should greatly simplify things. In this case, I am printing out the value of I, which will be 0. Then I'm going to pass I to do by value. I've modified the body for these examples to be much simpler. I'm going to take whatever the value of I is and add 1 to it. So will I be 1 or will it be 0 after we pass it by value? Well, here again, we're only passing a copy of the value, not the value itself. So we would expect this to still be 0 once we come back out of our method and we get it printed here. However, in the second example, we're actually passing in the value by reference as indicated by this reference keyword, ref keyword. So when we add a number to it, we would expect then to see it represented back out here in code. So let's go ahead and run the application. You can see that's exactly what happens. All right. So if you don't quite get this, don't worry about it. It's not that important. You might come across situations where you see the ref keyword and it's a little bit confusing to understand the difference between by ref and by val. I just wanted to cover that briefly. How often will you actually use this? Not often. But if you ever do run into it and you see it in a code example, it could really throw you for a loop. I needed to cover this for that purpose, okay? So let's move on from there. In fact, let's just recap what we already know about classes so far to get back on the same page. So a class is simply a blueprint, and an object is an instance of the class, an instance of that blueprint. A new instance of a class is created whenever you use the new keyword. Creating a new instance of a class using the new keyword creates a space in memory large enough to hold an object instance, and what's returned is the address to that object in memory. So then you can interact with that object in memory by using its address, which you hold on to using a variable. And that's what we've been calling an object reference up to this point. You can pass that object reference to a method through an input parameter, as we saw previously and as we've been discussing right now. But when you do, you're passing a copy of the reference, not the object, and not the reference itself. This is called passing by value. The practical implications is that if the method attempts to change the object reference, it will not affect the original object reference, but rather only the copy of it in the scope of that method. If you need to pass the actual object reference so that the method will modify the original reference outside of the method call, then you have to pass using that ref keyword, which is known as passing by reference. Okay, so now we're back on the same page. All right, so let's move on. Let's talk about this code one more time. Car, my new car equals new car. So notice the parentheses at the very end. And recall that a set of parentheses is the method invocation operator. Whether you realize it or not, you're calling a method whenever you create a new instance of a class. This method is a special method called a constructor, and it allows you, the developer, the option to write some code that will fire off at the moment your class is instantiated, when a new instance of your class is created. constructors can be used for any purpose, but typically they're used to put the new object into a valid state, meaning that you can use it to initialize the values of the properties of the object so that it's now usable by your application and you don't get things out of order, so to speak. All right, so let's create a really quick example. Let's go back down to our car class here. And suppose I wanted to create a constructor. I might do it right here between where I've defined my properties and defined my methods. I'll create a new constructor. And that's all there is to it. So we have created a constructor. Now this constructor does absolutely nothing. But we could do something like this. Whoops, let's do this. Remember the reason we use the keyword this? So this dot make equals, oh, I don't know. Let's choose Nissan this time. All right, so whenever we create a new instance of our class, what I'm going to do, and let me comment all of this stuff out. Let's go console.writeLine. Right, and let's run the application. So we've created a new instance of our class, and immediately we're going to do a get on the make property, and we'll run it. You can see the make is set to Nissan. So we were able to initialize at least one property in this pithy example to the value of Nissan. So extending this notion, we could grab values from a text file or a database or whatever the case might be in order to initialize the new instance of the class that we've created. Now there's another option as well, and what we can do is create an overloaded version of this constructor method. Recall from our discussion about helper methods that we can create more than one version of a single method by changing the method's key signature. And to do that, what we'll do is this. So now it looks identical. To change its signature, I'm going to do this, and so we'll set this dot make equal to name, this dot year equal to year, and this dot original price equal to amount. All right, and notice I purposefully did not use, in a couple of cases, the same parameter names as I did the actual public properties. Okay, so now if I were to go up here and comment out this line of code, and I'll do my new car, my new car equals new car. When I open up the first parenthesis, notice that IntelliSense gives me two options. So we're looking at one of two method signatures. First one takes no parameters, and the second one takes 3 parameters. And so what I could do here is type in, let's go Ford 2010 and 40,000. Okay, and then we'll go ahead and leave this line of code where we print out the make at the very least. So let's run the application. And so we've used an overloaded constructor to initialize the values of our new instance of the car class at the time we created the new instance, okay, as opposed to using this more longhand form. And so we could create as many different overloaded versions of our constructor as we want to. We just need to add more here. Okay, so what happened then? Let's just comment all this stuff out. What happens when you don't define any constructors? How is it that this actually worked? Well, the fact of the matter is that no matter what, you will still have a constructor defined automatically whenever you create a new class. It's just a constructor that has no input parameters and no method body. So you can't get away from it. You have to always use the open and close parameter parentheses, and it'll be generated for you at compile time. All right, and while we're on the topic of overloaded constructors, let me say this. What if we were to create another overloaded version of this? However, instead of passing in the name, we want to pass in the color instead. When we go to build this or start debugging this application, we're going to get an exception. It already defines a member called car with the same parameter types. So this is the trick when it comes to defining overloaded versions of methods, constructors or other types of methods, is that the method signature has to be different. The names of the parameters are not what makes it different. It's the data types and the number of parameters that makes it different. So if we wanted to remove one of the input parameters like this, it will work again. Except for the fact that I have now created new problems in my code. Let's go ahead and comment all those out. But let's build it, and you can see it will build successfully. Okay, so let's move on now. You know, many times the classes that you'll work with related to building .NET applications, you may have noticed that they don't require you to create a new instance of them first. So you might see things like this on this slide. Array.reverse my array. How is that even possible? We didn't create an instance of array first, if you recall from our array example. Another one, datetime.now. We've used that a number of times. How is it that we didn't create an instance of datetime before we were able to access its now property? Same thing with string.format. We've used string.format several times, as well as console.writeLine. Why didn't we have to create an instance of the console class or the string class in order to access the writeLine or the format methods? Well, it seems like they just kind of pop out of nowhere and they're instantly available for us to utilize them. So how is that possible? Well, it's only possible because when Microsoft created the definition for that class and those methods, they define certain methods as static methods, or they define the entire class as a static class. And you can also create your own static methods and classes as well. Again, our objective here at the outset is just to help you utilize the .NET Framework Library. So again, our objective here at the outset is just to help you utilize the .NET Framework Library. So just know that some classes that you're going to want to work with will require you first to create an instance of a class, and others will be available as static members of classes. In other words, their static methods will be available without requiring you to first create an instance. But just so you can see how this works, let's add the C# keyword static to a new class. So let's go down here. In fact, let's roll up the car class so we can clearly get that out of our way here. And let's create a new class called public my class. And inside of that, whoops, there we go. Inside of that, let's create a method, public static void my method. And so then, if we were to come back up here, we would be able to use my class.myMethod without first creating an instance of my class. Now, doing that is easy. Explaining to you why you might even want to do that would require a longer discussion of design patterns and coding heuristics. And really, I just want you to know for now that you're going to encounter these in the .NET Framework Class Library. It's not really important for you to use them yourself. I wouldn't just go all around and use this without knowing why you're doing it. So what I'd really want you to do is just understand that when you're working with the base class library, you will see this happen, and you'll understand at least why it's happening from a code perspective, and then you can pick up the rest a little bit later on whenever you're designing your own code libraries. Okay, so again, we talked about a lot of different topics regarding classes and objects and methods and so on. We're going to continue working through these ideas in the next video, so we'll see you there. Thank you.